So inside of control flows, our first item that we're going to look at is a while statement, and we've got a little block of code here for our while statement. And what I'm actually going to do is show you guys the Python docs, the official Python documentation or the original Python documentation. And it actually contains a while statement here, and it goes on from earlier sections, but we've done the earlier sections effectively. So Python can do more complicated tasks, but more things than adding two and two together. So we're going to go and take a look at the Fibonacci series, just to have a little look at this as well. This is a link to Wikipedia and what the Fibonacci sequence does, but effectively the Fibonacci sequence keeps on adding it adds on the next number in the loop or in the iteration, so it is the sum of the previous two values. So here we've got 0 and 1. So then the first value, so then the next value is 1 because it's a sum of them. Then the next value is 2 because it's a sum of 1 plus 1. And then the next value is 3 because it's a sum of 2 plus 1. And the next value is 5 because it's a sum of 3 plus 2, and so forth. And it keeps going on. And this series goes on until infinity, and it gets there in a certain way. And there's a whole bunch of stuff in literature, and this is a very old thing that's been done. But anyway, Python does this very fast, and this is the example that's given in the actual documentation, and I can click on these triple arrows here. So this is the Fibonacci sequence, and here we're going to see some of the power of Python and basically how quick it is. And how convenient it is, should I say, in terms of doing performing operations. So we've got this Fibonacci series that's here, and it's the sum of the two elements. Basically, the sum of the two elements defines the next. So we're able to conveniently put this into like one comment on line number 4. And we're doing something that we've effectively seen before, and I'm just going to re-highlight that, I guess, over here, which is the first line of this code over here. Contains multiple assignments. So the variables a and b simultaneously get the new values of 0 and 1. So we're able to do multiple assignments. That's one thing that's given to us out of the box. That's quite nice. And the next thing that we have here is this while statement. And we can kind of like imagine already what it is, but while a is less than 10, and a has its value, so a starts off at 0 to start with, and then it's going to increase in value because we've seen that's what happens in the Fibonacci sequence in some way. So again, I guess I pull this over. The while loop executes as long as the condition a is less than 10 remains true, and we're going to see some things about it, but we could also change the conditions on it. We can have greater than or equals to or less than or equals to, and so forth. Then we're going to look at the body, and I've kind of like implicitly done this in part, but not really mentioned it until this point. So this is the first point that we're going to talk about, the body of the loop. And it says here, the body of the loop is indented, and indentation in Python is important. Indentation is Python's way of grouping statements. So just over here, we see this indentation. The default number of spaces is 4 for Python indentation, but you don't have to use 4 spaces. But what you do have to do is make sure that you are consistent with these spaces. So if we put in 1 extra space, we get this squiggly underscore, and we've got a linting problem, which is over here. If I can hover over it, and say the unindented amount does not match the previous indent. So our linter has found it. The linter that I'm using is Pylance. It's found this error. We are now inside this while statement, and afterwards we are outside of the block of code. So we're outside of the while statement, so we could do print finished. We just add that on over here. So the indentation in Python marks the block of code effectively that we are going to do, or the grouping of the statement effectively. So, and then the minute we step out, we're out of it. So this again, 1 space. Python doesn't like this. Python wants us to be all on the first line. We've not really mentioned or seen this before, but this is an important feature in Python. And I'm just going to look and see if there's anything else there. The print function, no, we don't need to do that. So that's basically everything. Now let's just have a look at how this actually operates. So we run our piece of code, and indeed we get 0, then we get 1. They are the first two values. And what happens is we step into this while function and we print A. That's what we're going to print. And then we're going to, so A gets printed, A starts off at 0. And then we're going to say that A comma B equals B plus A, B comma A plus B. And what that means is that A is assigned the value of B, and then B is increased by the value of whatever A was plus B. So B is the sum of the previous two values. So just scrolling up here just to see what yeah, I'm just getting the term right, but this is, we will actually give it its proper phrase, but this is multiple assignment. We've done multiple assignments on line number 5, and we've done multiple assignment on line number 8. The only difference is that on line number 8, the multiple assignment looks a bit more complicated, but in reality, it's actually pretty simple. The first variable in the assignment over here is equal to the first variable in the assignment on the other side of the equal statement, and the first and the second variable likewise is equal to the second variable on the other side of the equal statement. So as long as we understand that, that's what we get. And the print finished only occurs once. Now if we had the indentation in here and ran the same piece of code, it would keep saying finished. And the reason why is because this is now inside the block of code. So Python recognizes the block of code, where the block of code ends, via its indentation. Other languages tend to use curly braces. So the curly brace would effectively have started here and ended over here to represent the block of code, but Python doesn't do that. Python has what is known or is called to be a clean syntax, so it uses white space conveniently to do this, and so long as we adhere to this, we have a very fresh and convenient way of running code. I'm just going to do the second example, so I'll just pull this back over here, which is the second example. I have to click on the triple arrows. It saves me doing the writing, and you can also see where it comes from, which is the original documentation. I've just copied that and I'm going to paste it in here. So after we've done a finished, we're going to run our next piece of code. We could actually just print some blank lines as well, \n/n, there we go. So we've got some blank lines at the end, but let's just see what happens here. We set A and B equal to the values of 0 and 1 respectively. So we've done our multiple assignment again, and we've said, let's do this loop while A is less than 1000, print A, and we've just changed one thing in here, which is we put an end and then a comma. And what that does is instead of printing to a new line each time, it just appends the print statement at the end of the line. And the reason why is it was okay to do this over here where we just had 8 loops. But what if we had 1000 loops? Then all of a sudden we'd be scrolling down forever. So this is a new introduction. We can put other things in the print statement. Again, we haven't put anything really extra into the print statement. We have used f strings, but we haven't used this end feature. So this is quite useful if you're going to print out a large series. And when we run it, which is down below, we see that we get this over here, which is the same thing. So we've effectively done the above function, which is this Fibonacci series. We've gone all the way up to 1000, and we've done that very fast. And also you just note, but this isn't the proper timing of the function, but in the Jupyter Notebook on the side as a side note, it's taken 0 seconds to do this computation up to 1000, and we could have introduced an extra 0 there. I might throw this in as an additional feature. We can run it like this, and we're going up even further. But alternatively, we can put an underscore just to show that that's 10,000 and Python recognizes it like that. So that's pretty much it. Let's just go back down. Let's just make this 10. There we go, or whatever we go. So we can go as high as we like or as low as we like. We'll go back to 1,000. But that's pretty much it. In fact, what I might do is I might just keep going up a little bit more each time and see where I break the interpreter. So we've gone up to 10,000. That's taken still 0 seconds. We will do 100,000. And it goes on. Notice now that the bar at the bottom sort of like scrolls across. And let's try to go to 1 million. So we can't put commas in here. That would ruin everything. So, but we can put underscores. Again, different languages do different things. This is Python's clean syntax. So we've gone all the way up to 1 million, and we've done that exceedingly fast in Python. And that's like an example of the Fibonacci series. And in particular, we've used the while statement in Python, and that's generally how it works. One thing that we do need to be careful of is if we do a while true, then the statement will just keep running forever and it will go into an infinite loop. So we need to be careful about this. I haven't introduced it, but we will talk about a break clause, and when we do, that will certainly be one feature of the while true, because we definitely want to make sure that we don't run things infinitely unless there's a good reason to, like we want to leave our server open looking for things. So that's just a general introduction to the while statement in Python.